Now let's look at problem 11, in which a tetromino is given that consists of 4 squares connected along their edges. There are 5 possible tetromino shapes which are given here and which can be rotated or flipped over. 3 tetromino are used to completely cover a 3 by 4 rectangle. At least one of the tiles is an S tile. What are the other 2 tiles that we have to answer? So we are told that one of them is S, so we can make, let's say, S tile here. Okay, so let's say that this is the S tile that we have. And now what we have to do, we will eliminate the other possibilities. So if we are putting S here, so it means that O is not possible, so we can eliminate this option. The second option that we can eliminate is T, because if we see, we cannot also fit T in this shape. If we put S here, we can also eliminate this option. And same, like we can use I. If we use I here, then we cannot use another I or L. So it means that this is also not possible. And now we can check the remaining option, that is L. So if I put L here in this direction, no, I can put L like this, and then I can also put second L like this. So by rotation, so now it will meet the requirements. So it means that our other 2 tiles, in order to make this rectangle, are L and L. Since for these exams we cannot have multiple solutions, so therefore we don't need to even check D, so you can leave this out. So the answer is then C. Look at problem 12. In this problem, we are given this figure that consists of 24 squares and each with side length of 1 centimeter. And we have to find the area of the largest circle that can fit inside the region, and it can touch the boundaries, but it cannot cross the boundaries. So the circle that meets these requirements, I have already drawn up here, that can be seen. Now what we have to do, we have to find the radius of the circle so we can get the area. So for that, what we have to do, we can draw a triangle, and then we can see that this is 1, this is 2, and this hypotenuse of this triangle, this is the radius. So the radius is equal to then 2 square plus 1 square, that is square root of 5, and the area is now pi r squared, pi this, and then that is 5 pi. Okay, so this is the answer, 5 pi. So now let's look at the next problem, that is about finding the number of times each remainder occurs. Now let's look at problem 13, that is about finding the number of times each remainder occurs when we divide even numbers from 2 to 50 by 7. So in order to solve a problem like this, it is better if we create a list of the possible remainders first. So we have 0, we have 1, 2, 3, 4, 5, and 6. And then we can simply list the number of times each remainder will occur. So for example, when we will divide by 14, 28 and 42, we will have a 0 remainder, and for 1 we will have 8, 22, 36 and 50. We will have 1. For 2, 2 will itself be there, then we will have 16, 30 and 44. For 3, then we have 10, we have 24 and 38. For 4, the options that we have are 4, 18, 32, 46. For 5, we have the options which are 12, 26, 40. And for 6, the options that we have are 6, 20, 34 and 48. So it may appear a bit daunting, but it is not difficult to create this list. The only thing is you identify the first one and then just simply keep adding 14. And I am adding 14 because we want to have the number even. So if it would be odd, then we can add 7 as well. So similarly, we can create the list. Now we have created the list, so we can see like how many times each of the remainder is occurring. So we have 3, 4, 4, 3. Then we have 4, 3 and 4. So now we can see like where we have this pattern. So this is 3, 4, 4, 3, 4, 3, 4. So then A is our answer for this problem. Let's look at problem 14, where a number is inserted into the list. The mean is now twice as great as the median. What is n? So we have to find n. So let's say the list that we are given is 2, 6, 7, 7, 8 and n. So the mean is now twice as great as the median. So the new median that we have, that is 7 plus 7 over 2, and that is 7 for this list. And the mean, that would be then 14. So now what we have to do, we have to find n. So we can find n by having 14 is equal to 2 plus 6 plus 7 plus 7 plus 28 plus n divided by 6. And then what we get here, if we add these numbers, we get 50 plus n over 6. And then we have 84 minus 50 n, and n is equal to 34. So the answer is then E for this problem. So now let's look at problem 15, where Kai draws a 6 by 6 grid. He colors 13 of the unit square silver and the remaining squares gold. Kai then folds a grid in half vertically, forming pairs of overlapping unit squares. Let small m and capital M equals the least and greatest possible number of gold on gold pairs, respectively. What is the value of m plus m, meaning small m plus capital M? So, like based on the given information, we can see that he is folding the grid in half vertically. So that means he's making a cut here. And M represents the least number of gold on gold pairs. So there are silver squares are 13. So then gold squares are total 23. And the maximum pair that we can have on one side is 18, and similarly maximum we will have 18 on the other side. So for the M to have the least number of gold and gold pairs, we should have a maximum gold on one side, and that will be 18. So it means that small m then will have 18 and then 5 on the other side. So then we will have 5 as the answer for small m. But for the capital M, we want to maximize the overlap. So for that, we can divide this number by 2. That is 11.5. So this is then, we can have then 12 and 11. And then the overlap that will be for 11. And then the sum of the small m and plus capital M, that is 11 plus 5, and that is 16. So the answer is C. Now let's look at problem 16, where 5 distinct integers from 1 to 10 are chosen and 5 distinct integers from 11 to 20 are chosen. No two numbers differ by exactly 10. What is the sum of the 10 chosen numbers? So basically what we can do, we can list these numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have 11, 12, 13, 14, 15, 16, 17, 19, and 20. So if we see, the condition that is given is no two numbers differ by exactly 10. So that means we cannot have like these pairs, the ones that I'm circling in red, because all of these pairs, if I go all the way up to 10 to 20, so they all differ by 10. So I cannot have these pairs. So what other options now I have that I can use is I can select any of the numbers. 5, probably I can take these, and then I can take 5 from here. Or vice versa, you can also take these 5, the one that I'm highlighting in black, or you can take these 5s. And you can also take any of the other combination. However, regardless of that, the answer will remain the same. So let's take the ones that I circled in green. So I will then just write then 1 plus 2 plus 3 plus 4 plus 5. Then have 16, 17, 18, 19 plus 20. So now we can simply sum that up. So we have 20 already here, and now if you take this 19, 1, that will also give you 20. You take this 18 and 2, that is another 20. 17, 3 is another 20. And then we have what? We have 16 and 4, another 20. And then we can write 5 as it is. And the sum is 105. So the answer is then C. Let's look at problem 17, where we are given 3 cities, A, B, and C. There are 100 people live in A, 120 in B, and 160 in C. Everyone works in one of the 3 cities, and a person may work in the same city where he lives. And then it says an arrow pointing from one city to another is labeled with the fraction of people living in the first city who work in the second city. Okay, so let's first label it. We have 100 people here, and then we have 120 and 160. So first we find the people who are living in B and working in A. So that would be and then let's find the number of people who live in C and work there. So that is then, so we have 40 people here, and then we have 20 people here. And now we need to find how many people who work in A and also live in A. So that would be simply 100 minus 1/5 of 100 and minus that would be 1/4 of 100. So if I simplify, I would get 100 minus 20 minus 25. So that would be then 55. So now if I add all of that, I get 40 plus 20 plus 55. Then the answer is D. Now let's look at problem 18, where the circle shown below on the left has a radius of 1 unit. The region between the circle and the inscribed square is shaded. In the circle shown on the right, 1/4 of the region between the circle and inscribed square is shaded. The shaded region in the two circles has the same area. What is the radius R of the circle on the right? So to solve this problem, we will start with the small circle, and we know that the area of the shaded region that will be pi r square minus the area of the square. So I'm representing this with S. So we are given the radius, so we can just simply plug that here. However, for the square, we need to find the lengths. So we can complete this triangle, and now this is a isosceles triangle or 90, 45, 45, 90 triangle. So we can apply the Pythagoras theorem. So let's say this length is L, this is L. So we have L square plus L square is equal to 1 square, and 2L square is equal to 1, and L is equal to 1 over square root 2. So now if we need to find S, so S will be then equal to L plus L, that is equal to 1 over square root 2 plus 1 over square root of 2, then that is 2 over square root of 2 and square root of 2. So we can plug that here, and now we can say that it is pi minus 2. So now let's do the same thing for the right hand side. So on the right hand side we have pi r square, and then we are subtracting from there this circle, this square. Okay, so first we can do for the whole, and then we can apply for this only region. So if I do for that, I can again find this length and this length by applying the Pythagoras theorem. So again, if I apply, I will have then L square plus L square is equal to R square. 2L square is equal to R square, and then I will have L equal to R over square root of 2. And if I add, I will then get 2L, that will be equal to 2R over square root of 2. So that 2L actually represents this whole length of the edge. So I will then have 2R over square root of 2, and pi r square, that is now the area of the whole circle, and I am subtracting from there this. So I also have to now multiply this by 2R over 2. So then I will be having pi r square minus 4R square over 2, and then I'll have pi r square minus 2R square. So then the next thing is, since only 1/4 is shaded, so I will divide this by 4. And now I will put these two equal to each other and find the value for R. I have pi minus 2, that is equal to pi r square minus 2 r square over 4. R square common, I will have pi minus 2, pi minus 2 cancels out. I had 4 here and then 4, which gives r. So then this is how I can solve, and now the answer is 2. Problem 19. Where two towns A and B are connected by a straight road that is 15 miles long. Traveling from town A to town B, the speed limit changes every 5 miles, and the limits are given here. Two cars, one at town A and one at town B, start moving toward each other at the same time. They drive at exactly the speed limit in each portion of the road. How far from town A will the two cars meet? So to solve this problem, we can start with this formula, that is between the speed, distance, and time. And then in this problem, since both of the cars, they are taking the same time, so we can set up like this. Then time A is equal to time B. So since one car is going in this direction, the other car is coming in this direction, so then they will meet somewhere in this town. However, what we know, then they would have covered completely the first portion, like this portion and also this portion. So we can then write like, if I rearrange this, I can write it like TOS. So I can then write here 5 over 25, and then on the other side I can write 5 over 20. So now we don't know like where they will meet in this portion, right? So what we can do, we can then assume, let's say that this is, we can take it z, and can take then this is 5 minus z. So if we add that up, it is 5, right? So now we can add here that this is, the distance is z over 4d, and here we can say plus 5 minus z over 4d. Okay, so after that, all I have to do, I have to now solve for z. So for that, like we can start simplifying. So if I do this, I get 1 over 5. If I do this, I get 1 over 4. And now I have 1 over 5 plus z over 4d. And here I have 1 over 4 plus 5 minus z over 4d. So then I can simply multiply this 10 by 10, this one 8 by 8. And then here I'll have then 8 over 4d plus z over 4d. This one will be then 10 over 4d and plus 5 minus z over 4d. So then I can have it 4d, it becomes then 8 plus z. Here I will have 4d and it is then 15 minus z. So this cancels out, and then I will be left with 8 plus z equal to 15 minus z. And then if I rearrange, I get this, and then if I calculate, I will then get 7 over 2, that is 3.5. So answer will be then 5. that is from distance from this end 5 miles plus 3.5 miles, and 8.5 miles will be the answer. So that is D. Now let's look at the next problem. Sarika, Dave, and Rajiv are sharing a large block of cheese. They take turns, cut half of what remains and eating it. First, Sarika eats half of the cheese, then Dave eats half of the remaining, and this cycle it continues until the cheese is too small to see. So we have to find out at what fraction of the original block of cheese does Sarika eat in total. So there are three people who are involved. One is Sarika, Dev, and Rajiv. So let's say that we are having Sarika, Dev, and Rajiv. And we're starting with one as a whole for cheese. So Sarika, she's eating half, and then they will eat half of that, and Rajiv will eat half of that. And in the next turn, then Sarika will eat 16th. This is 132, and then this would be then 64. And similarly, like this cycle, it will continue for all of them. So if we see like what Sarika has eaten, so we can write it like this. Sarika is 1/2 plus 1/16. Maybe I can add another term, so that would be 1/122, 8, and plus this sequence it will continue. So if I now change it to the power of 2, it will be like this, plus 1/2 to the 7, and plus it continues. So now I can again write it like this. So now from here I can see that this is geometric series problem. As we know, there are two type of series. One is the arithmetic series and the other one is the geometric. So this is the geometric, where we have the common ratios, and when we want to find the sum for a geometric series, the sum is equal to a over 1 minus r. So a is 1/2, 1 minus, and r is the common ratio. So that is then 1/8. And now if I solve this, I will have then 7/8. And if I further simplify, then I'll have 1/2 multiplied by 8/7. So I will be having then 4/7. So the answer is A for this problem.